Hi, this is going to be, yeah, alright, let's start. So, today we're going to go over Intro to Java Applications. Go ahead. So, first thing, I had a lot of questions this week about the laptop policy. And one thing that we've decided is that they're not going to be required at meetings because, you know, liability of the laptop and, like, it's difficult for a lot of people to carry the laptop to the school and, like, take care of it. So it's not gonna be required. You can bring it in if you want and I can help you work with it, but it's not required. So what we're gonna try to do is we're gonna try to have you write code when you're over here in the class, which is exactly how it is on the AP test. And then when you're at home, you can type up the code so you can actually like practice computer science and like practice something that's outside of the AP test as well. And then when you're going to be coding at home, I'm going to go over this a little bit more, but you can send your code to me via email and I'll check it for you and let you know what you can improve on and how it is. So like I'll be giving assignments and labs and things that you can do, and you just have to email me like the code document and I'll check it and let you know how it is. So for the materials, I recommend, like, I'm going to be giving handouts. We're going to have one handout today, but there's going to be more and more starting next week's. And I recommend getting like a separate folder or like a tab in your binder for you to keep track of all of this stuff. And then it's necessary that you have access to the computer and internet to like be able to do this course adequately. So if you guys have any like trouble with that, feel free to come talk to me after the class and I can help arrange something for you. So if you're not, so all the lectures and all the syllabus and everything, like handouts I pass out, presentations, videos of the meetings, they're all going to be online, so you guys can feel free to participate virtually for some of the weeks if you're not available. And then there's two different types of books I'm going to be using to teach this course. One is the Barron's APCS book, which is in itself adequate for the course itself. It does a really good job of preparing you. And then the other one we have is Dato, I think. That's a really good book. It's an Intro to Java book that's also used for some APCS classes, but it gives also a better broad understanding of Java. So I'll be posting links to both of these in the Facebook group, and you can feel free to order them. And starting next week, I'm going to photocopy some of the pages that I'm going to be going over, so you guys can follow along even if you don't have the book yet. So generally, one thing, so some people have been asking me about lab hours, and for the AP class itself, lab hours are required. Lab hours, this was instated this year, where you would need 20 lab hours to qualify for the AP test. But I've done some research and I've discovered that's only required for official AP classes. So since we're not an official AP class, that's not required for us, but I'm still doing research and talking to different APCS teachers just to make sure. So I'll have an update on that next week. And then if you guys aren't part of the Facebook group yet, please join it right now. If you don't have a Facebook, let me know and I'll get your email and email you updates every week. And then let's try to get some more participation now, because this is like, last week was good participation, but like we want some more this week. And like the more you participate, the more you learn. So it's mutually beneficial. And then this week the meeting is Friday, which is a bummer for a lot of you guys, but starting next week, it's going to be back to Tuesday. And we are considering adding another class per week. We're still considering this. It's in the early stages, but there's a lot of course material to cover, and we want to prepare you as well as possible, so that's why. Okay, so reviewing the last lecture, we went over the class guidelines, software versus hardware, computer units and objects. And I was going to give you guys an in-class assignment, but I had a little bit of trouble with the printing and stuff, so no in-class assignment. It's going to be part of the PowerPoint. So if you guys could like take out a rough piece of paper or something and write down your answers to this, and even if you weren't here, give it a try. And then once you guys are done, we'll go over the answers. And if you participate and like even give a chance or like try, you get Haichu. So that should be an incentive. So give it a try. You can like type it up on your computer or whatever you think. These things might not be directly related to Java, but they're still really important parts of the course itself. The College Board tries to throw a few of these questions at you every time just to catch you guys off guard. So I'll give you guys a few minutes to work on that. And then once most of you guys are done, we'll continue on from there. Exactly, yes. No, keep it going.
We totally don't belong here.
Look what I did to Google. Nicole, look what I did to Google. I hacked Google and made it valid.
That's it? Wow.
No, check. See, if you go Leon. See, if you go on regular, this is a regular. This is the one that adds. That's the new one.
Make sure you just apply background.
Yeah.
Background, maybe.
Apply the background. It's not hacking. You know what real hacking is?
Yeah, hacking to the government, I could do that.
No.
But I don't want to do
You want a
it.
real hack? Okay, search up any image. I'll show you something cool. Search up any image. Any image you want, a background image, and I'll put it on the background for you.
Like what?
Anything. Lamborghini? Okay, alright.
Doesn't really
Alright,
matter.
I'm gonna put that on the Google site, okay? Okay, anything. Choose anything. You want that one? Choose it. Alright, save it. Alright, okay. Save it anywhere, desktop. Alright, there you go, alright? Go to Google. Regular Google, any Google. Alright, awesome. Watch this. Check this out.
Okay. Sorry, just give it your best shot. It's a good end. You can go where you are at right now, and then you can try to improve from that. I'm going over the answers. All right, guys. 3 more minutes before I go over the answers, so keep writing the answers down.
As. Technically,
If you guys have any questions about specifically about any of the questions, you can call me right now and I can help you out.
so technically now you've written down your Google of your thing. Okay, now depending on where you have your image, where you put your desktop, right? Copy that. Go back to documents. Paste it right here, right?
Yeah.
Now the cool part about this is you can put the image. You can put the image right in. Wow.
What?
No, nothing.
Is it hard?
No, it's not that hard.
What did you know?
So I'm gonna put an image, right? I'm gonna.
Okay, guys, 1 minute. 1 minute before we go into the answers.
What is this? A JPEG?
Did Google make it hard for you?
You want that guy? Did you win?
You can put any image you want.
All right, guys, we're gonna start right now. So, does anybody have an answer for number 1? Wow, that's better participation. Okay, give me one of them. Input? Okay. All right, Leo.
ALU.
All right, what does that stand for? Good job. Okay, anybody else? Aditya.
Secondary storage.
Huh?
Secondary storage.
Good job. Taro. Good job. Okay, Abhishek. Memory? Okay. Okay, last one. Yeah, you. Output unit, good job. All right, we got those. Now, what are the 3 different types of language?
English?
Any new participants who want
Spanish.
Ato. Machine language, good job. You know?
Now you have your.
Go ahead, give it a try. Okay.
Yeah.
So check this.
C++ is a language, but like we're going to classify it
Place
as
the iPad image right here.
But yeah, here.
Replace the
You
iPad.
gave it a shot. Good job. Anybody else? Yeah. Assembly, yeah. So we got assembly and machine. Last one. Yeah? Yep. Okay. All right. Somebody give me an example of pseudocode. Yeah, Leo.
So like, think of being X
Find it, right?
greater than pi, show this,
Let's
X
find
like
it.
less than this, show the other something else.
Yeah, exactly. Could you say that louder one more time so everybody in the room can hear?
So you have the thing that says like, so it says X, if X is some
Right
thing,
there.
then the outcome will be like, if X is greater than 5, show this result. If X is less than 5, show this result.
Exactly. So the thing with pseudocode is it's a way to establish your logic. So you're not going to actually write any code, like specifically code. It's going to be like plain English. So let's say I want to understand, if X is greater than 5, I want to print Moksha is awesome. If X is less than 5, I want to print Moksha sucks, right? And let's say that I set X to 6. So instead of writing a program, which you would in Java, you can establish and figure out what's going to happen in the program by writing it in plain English. And this is something even the top level programmers use to map out their program, because for them it can often get really complicated. And then the last question is, give a real world example of an object and some of its attributes and methods. Anybody? Anybody new? Anybody new? Alright, yeah.
Could be an object, some of its attributes is
All of a sudden,
yellow, green, and method.
Okay, so what he said is that a pencil is an example of an object. So the attribute of a pencil is it's yellow in color, right? So the attributes are like its adjectives, its descriptions. So like yellow, solid, right? Then we would talk about some of its methods or its verbs. So like, let's say for example, writing or erasing, right? Something like that. Why don't you show mine? Yeah, so we got all 6 of the 6 logical units of the computer, the 3 different types of languages. There's an example of pseudocode where it's saying if Moksha is cool, then you should take APCS. So all of you should be good job, you're taking APCS. And then for an example, let's say a Lamborghini is an object. And then the examples of it, it's yellow, smooth, pretty. And then some of its methods or its actions are something like it drives, it runs over people, it reverses, it drifts. Yeah, go ahead. Okay, bonus. This is for this is some extra questions. Can somebody explain the relationship between volatility and persistence? Yeah, Abhishek.
So persistent. Volatile is like short term and persistent is long term.
Okay. All right. Can you? Okay, that's cool. All right. Which unit corresponds to volatility and which unit corresponds to which persistence? Yeah, Sai.
Primary unit is volatile and then secondary storage is persistent.
Okay, that's good. All right. Next up, we have what are relationships between classes called? Yeah, Tara. What? Yeah, association. So we haven't gone over this in depth right now, but we're going to be going over it soon. And then this is going to become a really important part of our coding, but right now you're not going to be going over it in depth. And last one, what does UML stand for? Anybody? Yeah, Otto. Close, close. I'll give you a high two later. Close. Yeah, Abhishek. Yeah, good job. Can somebody give me an example of how UML looks? Like, what are some characteristics of UML?
I remember.
Yeah, Leo.
Box, and you put something in there, and you draw a line down, it's like a circle.
Uh-huh.
And like has like branches, things, outcomes.
Yeah, exactly. So what he's trying to say over here is that you have a box, which is a condition, and then
I just
you
use
go
the
down and you execute things. So think of it like a workflow, and basically there's different steps that you have to achieve, and you're going in order. Or think of it like your homework. You have different things. Like you're going to do your math homework first, and you're going to do your English homework, right? So you go in order. And then, let's say that you want to say, if it's 6 o'clock, in the evening, you're going to do your English homework first. If it's let's say if it's 7 o'clock in the evening, you're going to do your math homework first. So then what you would do is, you would have something like time over here.
I remember my mom using that.
And then, depending on the time, you would go to this or that. So that's something about UML, and similar to pseudocode, it's something that like top-level programmers use to establish the logic of their programs. Thank you for the participation, by the way. Yeah. Okay, so now we're going to talk about getting the Java environment set up. So a lot of you may be wondering, how are we going to be able to code? How are we going to be able to code? So I'm going to pass out a sheet to everybody which will help you install some of the things that you need. They're completely free and shouldn't be difficult to install. And then I'll show you the links on the computer screen itself.
Yeah, that's just not trustable.
In programming, there's two things. There's 0 and there's 1.
3 right here.
So those are called the bits.
Yeah.
Yeah, pass these down. 4 more right here.
So from these, 0 and 1, 0 and 1 is 2, right? 2 to the power of 8. 64. 2 to the power of 8. 8 to the power of 2 is 64.
Oh.
So multiply it 8 times. If you try that, look. 2 times 2 times 2 times 2 times 2 times 2 times 2 256. You have to subtract 1 because that's, and you do 256 bits, right? That's including all the zeros and ones. Yeah. Hey, look, we started off with 0.
Yeah.
So you have to take into account that 1 zero.
Okay.
So that's why you can only have up to 2 to 8
Okay.
of numbers.
Alright guys.
That's
great.
also a calculator.
So while you guys take a look over at the sheet, you notice that there's 2 things you have to install. One is the Java Development Kit, JDK, and the other is Dr. Java. So Dr. Java is like where you'll be typing up your code. So think of it as like the Microsoft Word for programming. You type up your code there. And the reason we're using this, there's a lot of different options. The reason we're using this is that it's very well suited for beginners. So as you guys get used to it, this will be perfect for you guys. And then as for the Java Development Kit, this is something that you need in order to, write your code. That's also another requirement. And right now I'm going to show you guys what websites you can download them from. So.
If you were to save this, how would you do it? Like, no, not like save them, like overwrite their website.
So basically the same thing, you have to save this and then purchase it.
Okay, so if you look right over here, you can see if you click that download button, the Java Development Kit will get downloaded, and then it'll just ask you if you want 32-bit or 64-bit. And in the PDF, which I'll upload online, you can click on the link to determine which one is best suited for your computer. And then for the Windows users, you'll just click the Save As, and you'll automatically save the Java Development Kit to your computer. And for Mac users, it will be downloaded as a .dmg file, which you just click on and it will be executed. So it's really simple, like you download anything else. And then once you download it and you run it for the first time, there's going to be an installation wizard, which is just going to make you say okay, and agree to the terms. And after that's complete, you guys can, like, for your homework, you'll be testing out a Hello World program. So you can do that just to make sure that everything is running. Now, as for Dr. Java, Kunal, could you go to drjava.com? .org. You put it. So this is Dr. Java. So if you see over here, so you can download the jar file or the Windows app for Windows users, and for Mac users, you can download you can click this button, and similarly, there'll be an installation process and there'll be an executable file which you have to click, like with anything you download. So that's it. I hope you guys will be able to do this over the weekend and get everything set up, so you can start coding at home as well. And if you have any problems, again, feel free to email me at moksjava@gmail.com. Okay, so this is a Hello World program. So Hello World program is like the basic program that every programmer, when they're learning, looks at this first, because all this will do is the computer is going to say, "Welcome to Java programming." Okay, now this looks really complicated right now, and the first time I looked at it, I almost gave up on programming. But right now, I'm going to walk through this step by step so you know exactly what's going on. And what we're going to be doing for this class is I'm going to be showing you different programs, and then showing you the different each line. I'm going to analyze each line of it so you guys know exactly what's going to happen. So yeah, go ahead. So when I ran this program, so this is in Dr. Java, that was my code that I typed up. So then what I did was I clicked compile, and then I clicked run. Now when I ran the program, the output came out as "Welcome to Java programming." So that's exactly what we want you to do. So if Kunal, you could go back one slide. So this code led to this welcome to Java programming being printed. So you have to click compile, run, and then the output is right below the code. Okay, so there's a couple of things about the Hello World program that I'm going to be going over today, primarily. So first of all, it's going to be color coded. So I want to talk a little about the color coding, the use of blank space, comments, class declarations, braces, the main method declaration, system.out.println method, and semicolon. This sounds a bit overwhelming, but it's actually relatively basic. Okay, so firstly, the comments, okay? So they're green in color. Now, could you go to the next slide? So if you see over here, these are comments over here. This, everything that you see in the green color is a comment. And is there one thing about these comments that you notice? Something specific that makes them green or maybe makes them stand out from all of the others? Yeah.
They have a double slash.
Yeah, exactly, a double backslash, which makes the computer know it's a comment. So in the case of comments, you could go back one slide. Yeah. So if you, in the case of comments, the computer doesn't read this. So when you click compile, the computer's going to ignore all the comments and only look at the code. So the comments are not required. They're a way for you to remember what you're doing and what's happening. So they're kind of like pseudocode because you can write plain English, you can write anything you want, and it's only for your reference so you know exactly what you're coding. Because when you write big programs, you often get lost where you're at, and comments help you speed up and know exactly what you're doing. Now, go back. So now, as you saw in the Hello World program, the double backslash, that's for an end of line comment, which is the comments that are being used here. And then if you see this, the slash with an asterisk and then ending with the same thing, that's a traditional comment that can be spread across multiple lines. So if you say your comment is really long or there's some detail that you want to go over, you would use that one if you're going through multiple lines. But yes, that's the program. Okay, now the class declaration. Could you go to the next slide, please? So over here, this is the class declaration. These three lines: public, class, welcome. Go back. Thank you. So as it says right here, so the keywords are followed by the class name. So public and class are the keywords, while welcome is the class name. Stay on this. Okay, so those are the keywords. And the class name is like an identifier and it has no spaces. So class names are made out of letters, numbers, underscores, and dollar signs. So those are the only characters you use, and it's just a way of naming your program. So it's not anything important. You can name it to whatever you want. You can name it table, moch, but it's usually relative to what it is. It's like the title of your essay. It's exactly what it is. And then it's case sensitive, so lowercase with a capital C does not equal lowercase with a capital L and a capital C. So keep that in mind when you're writing your programs. And then just to go briefly over what a class is, which we did last week, a class is just a blueprint for an object. So an object is basically, let's take it in a real world example. Let's say we're looking at this water bottle, right? This water bottle is an object. Now, what are some characteristics of this water bottle?
It has water in it.
It has water in it,
It's
yeah.
plastic.
It keeps water, yeah.
Plastic.
Plastic. Okay, what are, yeah, go ahead.
It has a red paper here.
Exactly. Now, what are some of its methods? Yeah.
You could throw it at someone.
You could throw it at someone? Yeah, I love doing that. Anything else? Can I hear something from anyone over here? Yeah, there we go. Huh? Yup. Anyone over here? Huh? You can drink it. Okay, that's still right. You can use it to hydrate. Okay, that works. So this is a water bottle. Now, this is an object, okay? This water bottle is an object. Now, consider a class to be a bottle. A class called bottle, okay? Now, this bottle class, everything that's in the bottle class will be used to contain liquids, right? Now, this object, or a water bottle, is part of the bottle class. So objects are part of the classes, and they have the same attributes as the classes. So for example, the bottle class has an attribute that it keeps water, and this keeps water. So you can see that everything that's an object inside of a class has the same attributes as it. One more. Okay, so now we're going to talk about braces. Can you go one more? So as you can see, this is a left brace and this is a right brace. Now what they signify is the start and the end of the body or the method. So they're always used. So when you're declaring the class, you want to know the computer is really stupid. Consider the computer to be the stupidest person here.
Don't say it too loud, it'll hear you.
Okay, yeah, we'll be careful of that. So the computer is really stupid, and it doesn't. It really, if you make a simple mistake, it won't understand what you're doing. So it needs to know where this class starts and where it ends. That's why this left brace signifies it starting, and this right brace, thank you, Kunal, for the mouse, signifies it ending. Go back. Okay, yeah, so as it says, the left brace and the right brace ends the body. Can you go one more? So now about indentation. Now you can see right here, right after I declared the class, I indented to the left. Then I kept on going in the body, and after I declared a method, which I'm going to be going over soon, I indented to the left again. So one thing about Java is you want to keep on indenting to the left as you define more methods and classes. And this is something that seems really abstract and vague right now, but as the class goes on, you'll try to get a better understanding of it. Right now, it's just something like that you want to remember. Good. So now the method declaration. So this is a method declaration. The main method begins execution of Java application. So that's a comment which is telling us about this line. Public static void main parentheses string args. Okay. Now this honestly seems complicated. And even I was thrown off by it at the beginning, but it's something that you have to try to kind of memorize, but it's also something that you'll understand as we dive deeper into it. Right now, if I try to explain it to you guys are just going to get confused, so I'm not going to go over it right now, but I'm just going to say a couple things. So now you see these parentheses, right? These parentheses over there, they signify that the line is a method, right? So this is called the main method. The main method is the central part of the class, and it's the method that is run. So you can see that over here that has some keywords like public, static, void. These are keywords that we're going to be going over starting in the next few weeks. But one thing that you can keep in mind for now is the void keyword means that this method does not give you anything back, right? So that's just something you can remember. It doesn't return anything. It's something that we're going to go over in a lot of detail down the road. Okay, next, the print method. So that the method we previously saw was the main method, and this is the print method, which is inside of the main method. Can you go to the next slide? Okay, so if you see the print method over here, you can see it's this line, system.out.println, parentheses, welcome to Java programming, semicolon. Okay? Yeah, quotes. These are double quotes, okay? Now, if you recall, the outcome came out as welcome to Java programming without the quotes, and that's something you have to remember. So one thing about this is that this is a method. How do we know it's a method? What? Yeah, exactly. So there's parentheses over there which show that it's a method. And then what this is doing is it's telling the system to output this line and print it. Welcome to Java programming. So this part, welcome to Java programming, is considered an argument. It's basically what you're telling the method to do. For those of you who remember algebra, like for example, if you have a function and you say function of 2, 2 is the argument, 2 is what you plug into the equation. So consider this to be plugged into an equation. And this method is already pre-built into Java, so you don't have to worry about it. You can only call the method. Okay, yeah. Okay, now one thing I wanted to go over especially was compiling. So as I mentioned, you press compile and then you press run using Dr. Java. I don't want you guys using command line or terminal. For those of you who do, I don't recommend it. It's always easier to use it when it's within the code, the editor or the place where you code itself. And let's try to keep it simple. Let's not try to get over, like, I used to use terminal, but then it gets too complicated over time and too tedious. So then I moved back to using my Dr. Java. Yeah, go ahead. Okay, now there's one thing which is called escape sequences. So the backslash, or this symbol right here, this symbol is called an escape character, and these different escape sequences are something that you can use when you're printing something out to move to different parts of the line or the output. So for example, \n moves to a new line and starts printing from the next line. So what it does is, let's say that you're printing something, as soon as the computer reads \n, it'll move to the next line. And then \t similarly moves one tab to the right. So you know how you tab to indent on your essays? Similarly, this moves one tab, but it stays in the same line. Then we have \r, which is carriage return. This actually was I think like the first question on the APCS that I took, and it was what does it stand for? So keep that in mind. They always have one question about that. And basically what it does is, it takes you, the line you're on, it takes you to the beginning of that line. So let's say I printed welcome to Java programming, and then I did \r. It'll take me back to the beginning of the line, and there, as the computer prints out more information, it'll overwrite what was already written. So for example, is there an eraser? Okay, so let's say for example, I print, let's say, I'm gonna keep the print method simple. This is not actually what you type, but let's say it was something like, okay, so let's say I did this, okay? Let's say I wanted to print Java \r hello. So what it would do is, the computer would first print Java after reading this, and then it would see the \r, which means even though the computer is over here right now when it's next about to print, it moves back to the beginning of the line, and then it starts to print hello. So as it prints hello, it's going to erase the H, it's going to erase the J and put an H there. So it's going to, as you can see, it's going to start overwriting the letters as they come. So then the A gets erased, and then you have hello. So then this turns out to be hello because the \r made it move back to the beginning of the line and then start overwriting everything already written. The next one is \\, which is, as you notice, the computer reads \/ to be part of an escape sequence. So if you put 2 backslashes, it'll actually print a \. And then the last one we have is \, which is, so as you notice, like when you're printing it out, the computer interprets these quotes to be as part of something called strings. Now strings are just like a combination of text and programming, but you denote them by putting quotes on both sides of them. So the computer is able to identify the strings because you put quotes on both sides of them, and they're color-coded red in Java, and they basically let the computer know that this is some text that needs to be printed and not actually interpreted. So if you, let's say you actually want to have double quotes as part of what gets printed out, you would put the \/ double quote in order to actually print out a double quote. Yeah. Okay, so now let's take a look at this line of code. System.out.println welcome \n to \n Java \n programming exclamation mark, and you notice the double quotes and semicolons at the end. So now can somebody please tell me, can somebody guess actually, or like think what you, based on what you've been told, what the output's going to be? New hands, new hands. Okay, yeah.
Welcome, new line to new line Java, new line program.
Exactly. Kunal, could you connect it? Thank you. And I think I owe you one, right? Yeah.